All right, so if we are solving this inequality, and notice that this is in a quadratic because of the 2 there. Inequality, because we have a less than sign there, less than or equal to. And it's only in one variable. I only see an x. So this is a quadratic inequality in one variable. And we have to solve it. So remember, if this was an equation, right? If this was an equation, x squared minus 2x minus 3 equals 0, if that was the question and I needed you to solve, we would be looking for what? Who remembers? What on the graph are we looking for to find the solution to this equation? Anybody? The zeros, right? Or the x-intercepts, right? So that's important. That's important because we do need to identify the x-intercepts because there's an or equal to here. All right. So how do we solve this? Let's say we aren't given anything else other than this, just to solve. One of the ways you could do that is to graph the function. Graph the corresponding equality, which is this right here. And that's what we did down here. We graphed it. And you can graph it by using a table of values. You can graph it, graphing technology maybe. But it's going to be pretty important for us to find out what the intercepts are. Could we, well, actually, I'll save that for the algebraic method. Well, actually, no, intercepts here. Could we factor this? That might be handy if we could factor this, because then you could find out what the intercepts are real quick. So can we do that? X minus 3, x plus 1, right? So we have x-intercepts here of negative 1 and positive 3. And you see that's what these are on the graph. Okay. So when you graph it, you might want to try and factor it or find the zeros so that you can place this. Then all you need to know is what's the a value? Is it positive or negative? Because right now, if I didn't have this graph, this is what I would have: negative 1, positive 3. If this opens upward, guess what? It's going to look something like this. Doesn't really matter how far down it goes. It's going to have these intercepts and it's going to open upward. That's all you need to know. It's either going to be that, right? Or it's going to be this. If it opens downward, it's going to look something like this. Those are the only things that you need to know. So this one opens upward as we see in the graph over here. Okay. So to solve this, well, this is a less than or equal to 0. So what we're looking for is where is the graph either equal to 0, so those are the intercepts, and where is the graph hanging below the x-axis to make this in negative territory, right? This is the negative. This is positive. So where is it less than 0? Well, the solutions are the x values between these two intercepts. And you would write that. Now, this is one way of writing it. I don't make you do all this stuff, but I would suggest you do solution set equals. They do use the braces there. Everything between negative 1 and including positive 3. So that's good enough for me. I will assume that it's all real numbers. So you don't have to write that. And you don't have to do this x such that. You don't have to do that part. So for me, I'm not too concerned about these things. Just this right now is fine for me. Okay? Just get the region correct. Get the solution set correct. All right. Now, method 2 would be finding the roots, like we did up here, and just using test points. So finding the roots means we factor the quadratic and find out the roots. Now, here's where the number line comes in handy, guys. Watch this. So if you plot these on a quick number line like this, what you should do is test points in each region. Test points in each region. So an x value of, let's say, negative 2. That's clearly in this region. And all you do is you put in negative 2 in for x. And you find out what this is compared to 0. So find out if this is less than or greater than, right? So this is going to be 4 plus 4 minus 3 is what compared to 0? That's 8 minus 3, 5. So 5 is clearly greater than 0. So that means that any x value in this region right here is going to yield us, the function is going to be greater than 0. You see that? Because here's the function, and that yields greater than 0. So is that what we're looking for? Less than or equal to. Okay. So that means that this is not part of the solution set. You see that? And you would just repeat that with points in other regions. So you would test 0 maybe, right? 0 is a good one to test always. That's 0 squared minus 2 times 0 minus 3. What is that compared to 0? Well, that's negative 3. Well, that's less than 0. So yes, this is the good region. We want this region, and we want to include the y-intercept or the x-intercepts as well. Okay? So that's how you could do this without graphing it. That's strictly algebraically. Okay?